developing, which is a really cool feeling.
Aspire is actually quite powerful when it comes to this kind of thing, using two rail sweeps, being able to use a shape creation, using our sheets feature. Hi, and welcome back to the 2023 Vectric User Group meeting. My name is Todd, and I've been working with the marketing team here for about 9 years now. In this presentation, I'm going to show you my process for working through a project like Victor. 100% of Victor was modeled in Aspire. 10 plus hours of modeling time, 3 days to slice and be sure we can put them all back together again, 14 sheets of HDU, 2 CNC cutters, 7 or maybe 8 days of cutting, 2 weeks of sanding, finishing, and assembly. Now, I'm not going to kid myself to think that you're ever going to want to build your own Victor, but I'm going to share with you some of the tips and tricks that I use to help me model certain parts of Victor. To get us started, we had to figure out what Victor was going to look like. We hired ourselves a professional illustrator that took some of our ideas and gave us about 4 or 5 initial sketches of what he thought Victor could look like. We decided to take all the bits and pieces that we liked, arms from one, spindle from another, and we put them together and resubmitted those to our illustrator for a final sketch. Once we were happy with that, we asked them to give us nice clean drawings that I could work from in our software. So that was a front and a back and a left and a right. And I used those drawings to get me started in our software. So my first initial file in Aspire, I only used to make sure that I could line up all the bitmaps properly so that I could start to develop the line art for Victor. While I was doing that, it was a great time for me to take into consideration some of the things I had to change. For instance, I wanted to be able to draw a line straight down through Victor's side, so I had a definite front and a back to him. This was great, except for instance, his head was tilted a little bit forward, so I had to actually push it back in the end. And I had to also think a little bit about parts of him, like his jaw, that actually go past the center point, and I couldn't really fix that by moving it around. It would have looked a little bit odd. Once I had that all done, then I could actually size up Victor, or his sheet up, to be the actual size that he was going to be. Now for this, I needed to take into consideration how he was going to fit on Becky's wall that she was creating, where the electronics were going to be inside of him that Sean was working on, and then also the biggest thing was his monitor, how it was going to fit, and the light bulb on his head. Once I had that all done, then we could go ahead and start to create some of the vectors I needed to model his parts. I did this all on the first sheet, or the design sheet, and then as I was going along and I was happy with the processes that I was going to use, I would copy them onto their own sheets so that I could respect the pixel density of those particular components. That way I had nice, clean models that I could use to build back Victor's parts again, all of his parts. For most of his parts, I could use some of the basic features of Aspire, so 2 rail sweeps, spins and so on, shape creation and all that. But some of his parts really needed some out-of-the-box sort of thinking. One of those things, again, was his jaw. And I'd like to show you how I got around some of those limitations of Aspire to create his head in the end. First of all, this file is a recreation of the file that I used to create Victor's head and jaw. The one that I really used was quite messy, so I thought I'd clean it up a bit for you. It got messy because, like a lot of these things, you try different methods to build the shapes of the components that you need, and in the end, you end up with something like this, which is a nice clean file that you can use to describe how you do things. So that's what we're going to look at right now. So as you can see, I've got a bitmap of the front of Victor here and the right hand side of him. These are really important because they help me to develop the vectors that I needed to create those components for his head and his jaw. So his head sort of being straight on, we're going to create half of his head front, and then we're going to copy that to the back, and then we'll add in his eyes and his mouth. And then we're also going to go ahead and look at creating his jaw, but we're going to create it from the side, mainly because, as I mentioned before, his jaw actually goes past the center of his head. So that required some extra out of the box sort of thinking to make sure that I could get that right. I didn't want to have to cut a jaw on its own and then attach it to its head. That ended up being kind of a long process, and it wouldn't have been as easy as what it sounds like initially. So we felt this was the best way to do it. Let's have a look at the head sheet that I have right here. So the head was really easy to create once I had the vectors. Simply, I had to just create half vector, so half a light bulb, half a socket, half his head, and we're going to turn those over to make the front half of those components, and then we're going to copy those to the other side, and then we'll create his eyes and his mouth. So to do that, we're going to go to our modeling tab, we're going to go to our create a shape by spinning or turning. We'll select half of the vector for his light bulb. We're going to go ahead and make sure we don't scale that to an exact height. We're just going to go ahead and add that in there. Actually, we're going to merge that in, and we'll hit apply, and then we'll start the next component. We're going to go ahead and just quickly go through these 3 parts. And that's how easy it is once you have those vectors all kind of sorted out. Now what I can do is I can go ahead and I can select all 3 of those components, go to my 3D view, and I can copy those to the other side. And because this is a 2-sided job, then you'll see when I rotate this over now, I've got a full head because I've got the front and the back preview turned on. So I can see both sides at one time. And that's exactly what I wanted to have happen. Now let's go ahead and talk about his eyes and his mouth. Now to do this, we're going to use the shape editor, and we're going to use a angular profile for all 3 parts here. Okay, we're going to always blend to an inner vector. And the thing that I want you to look at is it's obvious that there's a space between this outside vector and this inner vector. But when it comes to his mouth, it's not. But there is a slight gap there, and you're going to need to do that if you want to create a shape like this, because if not, it won't turn out exactly as you think it will. So let's just go ahead and quickly go ahead and choose these vectors. Subtract, and we'll hit apply. We'll have all the parts that we need. Now we can go ahead and close that down. And then what we can do is we can just select that component. And because it's a subtract component, we're going to need to pull up on our shape height handle. But we can go ahead now and we can modify this so the depth looks right for what we want. And I think that looks pretty good right there. So that's all it takes to build his head. It's really that easy, okay? The next part we're going to look at is his jaw. So I have another sheet set up over here. In my layers, I've got the actual jaw vectors turned off. I had them off because I didn't want to confuse you too much. Because in the front, you can see that I've got this jaw outline that shows where the jaw should actually be placed or its location. And then on the jaw sheet, I have all the bits that I need to go ahead and create the jaw. Now, because it's a 2-sided part, I've got vectors on both sides. You can see the vectors from the back side are kind of showing up through. Now, the thing I want to point out here is that these 2 lines here are exactly the same. I just chose to choose or select both of these lines and shift them over and copy them to the other side or move them to the other side. And that will define the wall thickness of my jaw, okay, which is about 0.75 of a millimeter. I know millimeters, you're wondering why I chose that. It doesn't matter the actual distance that I've chosen, and it also doesn't matter what unit of measure I choose, because in the end, this is just a demonstration. The actual theory behind how I did this is exactly the same. So just ignore that as long as you know that I moved them over the thickness that I wanted my wall thickness of my jaw to be. Okay, so let's go ahead now and quickly create this jaw. So I've got these 2 drive rails, and I've got a couple cross sections over here. So we're going to go back to our modeling tab. We're going to use a 2-rail sweep. So we're going to use these 2 drive rails. Perfect. We're going to select this cross section for the top and this one from the bottom. And you may be wondering where I got these shapes from. Well, they came directly off me drawing onto these bitmaps, so I knew exactly the shape that I need in order to make this jaw work. Okay, I can go ahead and hit apply. You see that in my 3D view, I've got sort of half a jaw, but I need to use this inside vector here. And I want to hold down my shift key and select the actual component, because what I want to do is I want to clear all the area outside that selected vector, and that will give me the profile of my jaw. Now it looks great and all, except for we have the solid thing, and actually I want it to be kind of a shape like you've bent metal around, so it has to have sort of a wall thickness. So to do that, I need to flip to the other side, And I've got those same vectors, as I said, I just shifted them over 0.75 of a millimeter. And I've got two cross sections here. So let's go ahead and do the same thing again. We're going to hold down our shift key, grab those two drive rails, use that selection. We're going to grab this guy here up top. And what we're doing is we're creating a shape so that we can kind of scoop out the back of this front shape. These are going to be, because they're upside down, it's going to be a negative component or a subtract component. So you'll see that in the end, when you view both sides of this component, you'll see that it's actually going to scoop out the back. So if I go ahead and hit apply, it's hard to see, but you can see that it actually scooped out the back of this. Now there's all this sort of extra stuff that I don't need. That's because there isn't any shared pixel from the front and the back to sort of zero those out of there. And to do that, this is a really quick tip and really important. If I just simply add in a zero plane to the back, go back to my front again, and put a zero plane in my front. Now those two zero planes occupy the same space, so that way they just zero each other out, they cancel each other out, and now I have my jaw. You'll see that the back here, there's that 0.75 a millimeter, but as I get closer to the top, because I haven't scaled down the actual shape height of that part that I used to scoop out the back with, then it gets really thin at the top. So to fix that, let's go back to our back again. We're going to grab this component. We're going to go ahead and take the shape height that we're going to minus 0.75 of a millimeter. If we hit equals, you'll see that as soon as we give it a second to apply, that now I have a jaw that's a consistent shape all the way through. And that's perfect. So let's close that down and let's go back to the front. Now, in order for me to be able to get this into my head sheet, I'm going to need to either copy it from here to the other one, which isn't going to help me any because it's the wrong side. I need to rotate this 90 degrees. So in order to do that, I'm going to create an STL from this, export it out, and then bring it back in again and paste it in to my head sheet. Okay, so to do that, we're going to go over here to our export to an STL. I'm going to use a nice tight tolerance here. I'm going to make sure I close with the other side. I'm going to triangulate that. And when I do, I'll be presented with a nice blue triangulated mesh here that I can use. Okay, let's just go ahead and save that off where I can find it. So we'll save that triangulation. We'll put it right in my folder where I'm working right now. We'll just call this jaw. And we'll save that. And now we can go ahead and close this out. And we can pop back over to our head sheet. Now let's go ahead and import in that 3D jaw, that STL model that we created. So it's jaw right there. Just select that and we're going to click open. Now all we need to do is just position that at the right angle that we need it to be. So we just need to flip it to the left. That looks perfect right where it is. That's great. And then we need to import and position that. And because I drew it at the exact size I needed, I don't need to mess around with any of the model size. It should come in just as I want it to be. So position, import. Now I'm going to go ahead and just line up that modeling plane. So anything above the modeling plane is going to be in the front side of my face or the head. And anything that's on the back of this modeling plane is going to end up being on the back side. So we're just going to go ahead and move that to right about here is where I want that to be. Okay, again, that's based on the drawings that I have. So we'll import that in. But before I do that though, I need to make sure that we create both sides, okay? That's really super important. Import that in. And then you'll see that in our 3D view, we have the front side of the jaw. If we go to the back side, it's hard to see, but we'll be able to see it just sort of peeking through here. So it's not quite lined up perfectly. So let's just go ahead and do that now. So the easiest way to do that is to align the front half of this half of the jaw with that vector that I created earlier. That kind of shows me where it should line up. Now you'll notice right away that this shape isn't exactly the same shape as I have drawn here, but that's okay. We're happy with the way it looks, so I'm not going to worry about that too much. And we're just going to position that where it needs to be, somewhere around there. That looks pretty good. We'll go up a little bit. Now we're going to go ahead and use a level effect to make sure that we can mirror that over to the other side. Now when we look at our component tree, part of the import process was to add in a few extra levels that we don't need. So let's just go ahead and right click on the ones we don't need and delete them. We don't need the tabs one. We don't need the limit plane one. We're going to delete everything that's there. Okay, we just need the jaw. Let's choose that, right click on that, and we're going to mirror mode. So the level effect, we're going to use mirror mode. It's going to right over left, and we'll see that in our 3D view, we have a full
two-sided jaw. Ignore what's happening here. We'll fix that in a second. So all we need to do now is to fix the gap. So we're going to just nudge over this front part of our jaw over till it touches the middle. There we go, and that lines up perfect now. Now I can select that, and I can choose to create a vector boundary from selected components. And when I do that, it's going to create a vector that's going to be for both parts of the jaw. So that's the mirrored model. And I can delete this one out of here. I don't need this guy anymore. And this is my finished jaw and the way it should look. Now what I can do to line up the back is flip to the back side of my jaw, grab this back bit, and I can just move it over, and I'm going to place it with inside that vector that I created for the front. Okay, and that looks really good. Let's not forget though, before we do that, we'll see that we've got this weird plane in here. We need to go and delete these extra levels we don't need, also from the import that we did. There we have it. Now all we need to do is just line up this jaw perfectly. And when we do, it'll all magically fix itself over here. You'll see we get some strange little artifacts going on here. There we go. It's lined up pretty good now. If I hold down my control key and nudge it into place, I can slowly just move it into place where it belongs. Okay, there we have it. That's lined up pretty good. Perfect. I like that a lot. Now we're going to do the same thing we did with the front side. We're going to right click on this level, and we're going to go down to mirror mode, and we're going to go right to left. And there we have it. So now we have the full head of Victor with his jaw in place, right where it needs to be. Let's just look at the front half of this. Flip it over. If we hide the modeling plane, we'll see that we have a nice 3D model with the gap like I wanted there. That looks really good, and everything lines up really well. So now I can go ahead and think about the next parts that we need to do. Now I might want to add in that shaft, that kind of the bolt that holds his jaw into place. We can do that later just simply by adding in a component, easy turn component, and then we can go ahead and glue on his bolts from the outside when we're all done. I think that looks really cool.
The next part that was quite interesting was his arm. And when you look at the actual drawings that we received from the illustrator, he has a patch on the side of his arm, and I had to figure out a method to get that patch to line up back on the side of his arm once we sliced him and put him all back together again. Also, this is a great time to show how versatile Aspire is, so I could build parts of his arms on different sheets and then put them back together again when it was time to slice it up. Let's go ahead and have a look at how I did all that.
So I decided that when we were going to model this up, that I was going to model the arms in 3 pieces. So we'd have a glove, and we would have a hose. Now we weren't quite sure how we were going to deal with this arm hose, whether or not we were going to cover it with some clear tubing, whether we were actually going to replace this maybe with some of the sort of that silver ducting that you can get for like a dryer at home. That's why I decided to do it in 2 different parts so we could replace this if we needed to. And then each arm would either have the pendant on it, like a CNC pendant, or this CNC crest. So I had to have one of each of those made up. Now there's nothing special here in the modeling. I am going to point out a few tips that I used as I went along. But as always in Aspire, there are all kinds of different ways to create models like this. So this is just my technique. You can come up with your own as you go along, or your own kind of workflow for this sort of a project. One thing that was nice about this though is I had these 3 parts for each arm, so I could move them around a little bit and adjust them as I was going when we actually get to the assembling of these 3 parts before I actually get into slicing it. So let's have a look at the arm hose. Let's tile our view for a second. Now this is a very basic 2-rail sweep. There's nothing again really special about this except for the way I actually drew my vectors. You see we have the 2 drive rails here, and then we have this line in between. This was so that I could line up these points here, the nodes here, so that when I apply my cross section to these 2 drive rails, when they get lined up, I should get a nice seam along here as I go. Okay, so let's go ahead and do that. So I'm going to hold down my shift key and select these 2 drive rails here, and we're going to go into our 2-rail sweep, and I'm going to use that selection right there. Notice they're pointing in the same direction. Now we're going to go ahead and we're going to choose this cross section, and we're going to start to place it along these two drive rails. So the first one obviously lines up with the first two nodes. When I drop in the second one, you'll see what happens. It gets shuffled down over here. So I need to pop it back up in place. And I'm just going to work my way slowly down these two drive rails, making sure that both points line up where they should be. And this should give me a really nice result when I do the actual sweep process. Again, I want to make sure those are all lined up nicely. Scoot that along a little bit. Only take a few seconds. And if it overshoots a bit, I would drag it back and I put it back on that node again, just in case. I don't want any little weird errors happening here. Scoot that down. Seems a bit crazy, but what's nice about our two rail sweep is if I decided that along the way I wanted to change the actual cross section to change the shape of it, then I can go ahead and add in a different cross section if I want to. And then automatically a spire is put in the bottom one for me. So that looks really nice. So now all I need to do is just hit apply. Oh, before I do that, make sure that we have scale cross section with width. That way, when it comes together at the end here, it'll actually get shorter. So this dimension will actually change. The Z height will change as it moves through there. So it gets scaled properly. Sweep between spans doesn't really matter. We'll leave it on. And we'll just hit apply. And then our 3D view, as soon as it's all done calculating, you'll see we have the hose made. So that was pretty easy. And then what we can do is we can just close that down. And if we want to, because it's a two-sided part, we can right-click on that and we can say copy to the other side. And when we look at both sides of this model, you'll see that there's the other side of the hose. So it makes a nice, complete, round hose for me. That's great. That worked out really well. Again, the tip there is to make sure that all of your nodes line up, and you can position these cross sections where you'd like them on those drive rails. Now let's have a look at the glove. Now, this is a bit different. What I've decided to do was, it's the same sort of idea, but I'm not going to use a two-rail sweep. I'm going to use a turn. So I'm going to turn this half cross-section over the center line to create my glove. And I've done it in two different parts. I did it in two different parts because what I need to do is I want to crop, or I only want to keep this piece of this turn here. Now, in the end, I could have probably done it all in one turn and then cropped it out, or cleared the area of my component outside of the shape of the whole thing if I wanted to. But for some reason at the time, I decided to do it in two parts. Not really sure why I did that. But anyway, so what we're going to do is we're going to choose this half cross section here. We're going to go ahead and turn it again. Okay. We're going to make sure that we don't scale it at all. We're going to make sure we choose merge and we're going to hit apply. Okay, in the 3D view, I got this nice shape there. Start a new component. We're going to grab this piece here. Going to do the same thing with it. Apply that. Close that down. Happy with that shape. Now I want to go ahead and crop it. So I'm going to grab this closed vector in that part of my glove. And I'm going to go ahead and clear the area outside of the selected vector. And I'm going to end up with this. And that looks really nice. Now there are two things that I remember from the actual sketch of Victor, was that this looks like it's kind of smoothed over at the end, like rounded over, or I kind of perceive that in my head as being, kind of roundy. And then also the whole thing is kind of bent at the top, sort of cartoony like, so it kind of gives it sort of like a squishy look about it, if you will. So we need to go ahead and do that. So the first thing we're going to do is we're going to take this bottom bit and we're going to do a little bit of sculpting. So we're going to go ahead and smooth that. And we're turning everything all the way up here because really we just want to go ahead and just crush the edge of that nicely and round it over. So it's hard to see, but it is rounding it over nicely. Now I could have done this in the final stages when I sanded it down, or when we sanded it down, but I decided to do it here just so that we could get a good idea of what it could look like. That looks pretty good like that. So just go ahead and keep that and we'll click OK. And what we want to do is distort this so we can get that sort of cupping at the top. So I'm going to go ahead and insert in a new level. And I'm going to create a component from my composite model, so what I can see in the 3D view. So let's go ahead and do that. I'm going to hide level 1 here. I don't want to see that anymore. Let's select this component. And then we're going to go up here to our distort. I'm going to use the bounding box, okay, to distort this with. I can hit apply. And it's going to give me a nice little dotted bounding box here in the 2D view. I'm going to take this top span and right click on it, and I'm going to turn it to a Bezier. And that's going to give me these extra handles here. So now what I can do is I can distort this shape leaving everything here at the bottom nice and square like it is. But I'm just going to go ahead and use my cursor keys and nudge those two down, those two handles down a bit. And it's hard to tell in the 3D view because I'm out so far, but I'm actually distorting that a bit at the very top of this. So I can go ahead and decide how far I want to go with this to give it, again, that sort of cartoony kind of look about it. It's kind of roundy at the top. This face stays normal, but these start to kind of slope down a bit. Those would be hard to model like that. So this makes it a bit easier. I like that. Let's just close that down. And then there we have it. And again, I can go ahead and select that, right click on that, and I can say copy to the other side. And this will give me, again, a good impression once it's done copying that on what this thing will look like in 3D once we go ahead and put both sides together. And there we have it. That looks really neat. I'm really quite happy with that. So that's good there. Next thing we're going to do is we're going to go up and look at our glove pendant. So let's look at that sheet. Now I'm not going to go through all the bits that I used to model with. Again, I'm just going to show you some of the techniques that I used. Okay. First of all, these are just really basic closed vectors, nothing special about these at all. And the first thing I'm going to do is going to do a single line sweep. That's going to take this cross section, drive it up this line, and then I'm going to go ahead and use the tool here to clear all the area outside of my selected vector so I can delete all the extra component I don't need. And I end up having this little pad. Now this same shape I'm using for both the pendant and the glove, okay, or the same cross-section shape. I'm going to crop it to a different shape, but this time I've got this pendant shape here. Let's hide that for a second. Then we're going to go ahead and build up our pendant. So we have this base with rounded corners on it. Give it that kind of, again, a nice sort of smooth look about it. We're going to add in a recess for some of our controls. We'll add in some fancy dials here. Again, these are just really basic modeling, like building up planes, limiting height of the angled forms and so on. Really basic stuff. But we can build those up or add those together to make this nice looking pendant, which looks kind of neat, this little swirly dial on it. And then what I can do is I can use this component, that original component that we saw, and bend those into shape. So when I add that back on again, you'll see that it's bent all of those components to that surface. So again, if I hide that, and if I show it again, you see how it adds all of those components to the top of that bent shape to give me that rounded look. And so if you ever want to do that, my tip here, I guess, if you ever want to do that kind of curve shapes, then build everything flat and then add a curved shape to the bottom, and that way you can have that look if you want. Now this last component up here, it's a little teeny dial that's going to show up at the bottom, and that really, we're going to cut that on its own and we're going to glue it to the side of this. That way we're going to give this a really nice 3D look. So all the controls just won't be on the face of this, there'll also be one on the side of this pendant. So that'll look kind of neat in the end. Now let's go ahead and have a look at the glove. Same sort of thing here with the glove. It's not overly complicated. We're going to start off with the sort of feathery look at the bottom. That's using a 2-rail sweep again with this cross section here. So between these 2 rails, you get this kind of feathery looking thing. We're going to add to that or merge into that, excuse me, a base that I've taken again and smoothed just this face of it, not the rest of it, just the front face of it with my sculpting tools. Gone ahead and added this. This is just a dome shape created between using this vector, this closed vector, and I've got this sort of funny little divot in there that I modeled in based on what the illustrator had put in there. This looks kind of neat in the end, gives it that kind of leathery organic feel. Here we have our CNC text. Now to make it stand a little bit better, I've gone ahead and added some draft to that, and that way I get these nice walls here. It gives it a much nicer look in the end. And then we can add back onto that, like we did before with the other pendant, that dome shape at the back here. So you can see that's right there. I'm going to take it off. Then we'll add it back in again. So I built everything flat, and then I add that dome shape to the back to give me the right shape that I want. Now I have all the bits that I need to go ahead and create the arm. So what I'm going to do is simply go back, and each one of these individually, I'm going to go ahead and create a brand new level because I'm happy with the results that I have here. It's a new level, and I'm going to go ahead and create a composite model from what I can see in the 3D view. I'm going to hide this. We're going to rename this arm hose, and then I can go ahead and right click on that, and I can export that out as a 3D clip file so I can bring those back in one at a time to build up his full arm, so then I can go ahead and create the pad where we're going to attach these plates to. And I can also go ahead and start to think about slicing things up. So I'm going to go through that right now, work through that, and then we'll come back with a brand new file that will be the right size of one of the sheets of foam that I have. Okay, so I've gone ahead and created a brand new job. Now this job is the same size as the sheet of HDU that we've ordered in to cut Victor into. So we have 14 sheets of this. So it's a single-sided job. The width of this sheet is 1500 millimeters. The height is 500 millimeters and the thickness is 50 millimeters. This is important, this thickness, because we're going to need to know this later when we actually go to slice up Victor. We're going to zero off our material surface. Our datum right now is set to the bottom left-hand corner. That may change later when we actually go to cut these things. Very high modeling resolution, and we can just go ahead and click OK. Now I'm going to go ahead and import in those 3D clip files that we saved off earlier. We're going to start off with the arm hose. Open that up. We'll just kind of move that to the center of our sheet here. We're going to bring in the glove. And then we're going to go ahead and bring in the pendant. Now the pendant is kind of neat because we're actually not going to use that model, except we want to actually get an outline from it. We're going to need that to create the pad for the pendant. Okay, so we're going to go ahead and select that, and we're going to create a vector boundary from that component. And I'm going to delete that component out of there. Now let's just go ahead and tile our view so we can get a better look at what's going to happen next. We need to go ahead and assemble our arm. So we're going to go ahead and move this guy down here like that, just roughly where it needs to be. Okay, then we're going to shift select both of those. Okay, and then we're going to go ahead and move it to the center. Press 9 on our keyboard to rotate that around. We're going to go all the way, actually. I could use 0. That would have made more sense, but anyway, 9 works as well. Now what we want to do is we want to rotate the hose so that this side part of the hose is actually at 90 degrees or attaches to Victor pretty flush. It doesn't matter if it sticks out a little bit, but we want to make sure that it's pretty flush. So that looks reasonably good right there. And I notice that in the 3D view, we've got these components are being added together. We don't want them added together. That's going to look really funny in the end. So over here in our component tree, if we select both of those, we can go ahead and change the combine mode to merge. And that will make everything look okay. That looks pretty good right there. Now let's talk about creating this pad that we're actually going to put the pendant on once we cut it. So again, that's why we need this vector outline. So if we go into node mode here, pressing N on the keyboard, we've got these top and bottom spans. If I right click on that, I can go ahead and insert in a midpoint. The top one, we'll do the same to the bottom. And then we're going to hover over those midpoints and we're going to right click and we're going to choose cut, or we can just hover over it and press C on our keyboard for cut. I don't need that half of it, so I'm going to press delete on my keyboard. All I want to do is just keep half of this, and we're going to rotate that around. Hold Alt on my keyboard, that way it'll snap to the angle that I've got it set up for in my preferences. Now what I want to do is I'm going to use this to actually extrude a pad. So to do that, I'm going to need to place it approximately where I want it to be. Go to my drawing tab and I'm going to draw 2 lines. Okay, one from here to there. And I'm just going to go ahead and copy that line. So holding down my control key and alt, just snap it over here to this other end. And then we're just going to nudge this out of the way for a second so we can see what's going to happen. So I'm going to take this cross section and I'm going to extrude it along these 2 lines, and it's going to merge into the arm or the glove where it needs to be. So let's go ahead and do that. Use our 2-rail sweep feature. We're going to grab this. And this will be our drive rails. We'll grab our cross section. We have scale cross section with width turned off. It doesn't matter. It could be on or off in this case because these don't vary in distance. They're always the same distance across each other, so it doesn't matter so much. We're going to make this a merge component and we're going to hit apply. And then we're going to close that down. Now, if we look at our 3D model, you'll see that it's pretty darn close. I did a good job, but there's a few little funny gaps here that are going to cause me some trouble. I want this to look like it seamlessly kind of merges in. So if I grab this component, I can just go ahead and use my cursor keys to nudge it into place so that's exactly where it needs to be. And now I've got this nice pad that I can go ahead and glue my pendant to when I'm all done. Now keep in mind this is only 1/2 my arm, so if I want to make sure this is correct, what I can go ahead and do is I can go over to my actual job dimensions and origin here, and I can switch this to be a double-sided job. We're going to click OK. And then I'm going to take these two guys, or all three of these actually, we'll press F9. And if I right click on that and I say copy to the other side, what you should be able to see when I go ahead and rotate the front around, that looking at the side, you can see I have that nice pad now. Once I go ahead and cut these two parts or all the parts together and glue them together, I should have a nice pad that's exactly the same shape as the pendant is when I'm cutting it top down. So that looks really good. Let's just go ahead and not look at the other side. Now one more thing I'm going to show you right quick here is how we can go ahead and slice this. So if I go ahead and select all three of those components, I can go to my modeling tab and I can slice this relief or the visible relief. Now I'm going to go ahead and slice. My thicknesses are going to be 50 millimeters. I'm always going to start from the back, not the top. Now this is important because I'd like that back piece to be exactly 50 millimeters thick. That way I'm not pocketing out a whole bunch of material and wasting all that. I don't mind that so much for the top piece because it's much smaller than the back. And also there's not a whole lot of relief to actually carve on these, so I can use that to my advantage in the end when I start to do my tooling. Now I'm not going to go ahead and create any boundary vectors. I'm going to leave it just as it is, and I can just go ahead and slice that model. Now it's added all those slices on top of my original model, so we can just go ahead and turn off the original components that I had, and then we can go ahead and pull away these slices. Now what's nice about this now is I can get a good sense of what changes I have to make in order to build a piece onto the top of my arm so that it can insert into Victor's body and I can hold him on there securely. And I'm going to get to that a little bit later.
Of course, that was only two parts of Victor, his head and his arm, but there was many more parts that I had to think about. Let's have a look at the file and we'll go through some of the other design considerations I had to make when I was actually modeling those parts.
Okay, this is the file that I use to actually model all of Victor's parts. Now, as always, on my first sheet is my design sheet, and I used that a lot during the process of developing Victor. As you can see, I used all kinds of different colored layers. If we look at my layers list here, there are tons of different layers, all named appropriately so I could keep track of everything. If we go ahead and hide the bitmaps here, you'll see that those are the test vectors that I used on that initial sheet just to see if I could get the shapes right, and then I actually moved those onto their own sheet so that I could go ahead and build the finished components. Now if we go ahead and take a look at the sheets that I have set up here, I've got a sheet for almost every part of Victor. Now that's what's important to remember about a job like this, is that it would be very overwhelming if we looked at this as a whole, but I broke it down into bite-sized chunks that made sense to model on their own, and maybe things may change. So if that's the case, I needed to have these in, small enough pieces that one little change wouldn't affect too much. So let's have a look at his chest here. Now with a lot of these parts, they were double-sided, so if we go ahead and take a look at his chest up close and we tile our views, you'll see that here's his chest. And it is double-sided, which is really quite nice, so I can make sure that everything fit together just like it should. Now some of the things I need to consider when I was modeling Victor's chest was the monitor. Originally in our illustration, you'll see that the monitor actually wraps around the front of Victor's chest. Well, in reality that couldn't happen. We couldn't bend a monitor to fit in there, so I actually had to create a flat pocket inside of his chest so that the monitor would fit in there. Now that's not in the actual model right now. This is a solid thing, but when we take it and we slice it, then we need to think about where the monitor cavity is going to be and how deep it's going to be. But I needed to make sure I accommodated that, and that's what these vectors here are for. This is the monitor with this little bevel at the bottom. This is the monitor offset, the monitor vector offset outwards just a little bit left and right so that we could accommodate his wires that plugged into the side of the monitor. And this one here was just for a little bit of extra wiggle room because I wanted to make sure everything fit in there nicely. And that was pretty easy to develop. There wasn't much going on here, some very basic shape creation, and that's pretty much it. It wasn't all that complicated to do. The next sheet is, of course, his head, which we've seen me model most of it earlier on in this presentation. But I did want to point this out, that in this version, I've got the actual rod that goes through to hold his jaw in place. And also I have the vector here that I'm going to use to cut out the bolt that goes on the end of his jaw here. So it'll make it look really, truly 3D in the end once we have it all done. Now the nut and the collet were interesting. I decided to go ahead and cut the nut from the top down. That way it would be easier to assemble in the end. Along with, we weren't quite sure how many finished parts we were going to have for Victor. So if we had this separate, then I actually could make the collet shorter if I had to, for whatever particular reason. In the end, we didn't actually cut out the center circle here. That was there just so I could show Sean that there was room enough for some electronics if we wanted to go ahead and do something with the actual V-bit at the end of his collet, which we didn't do in the end, but I just wanted to make sure there was space there for it. The collet was a very simple little turn. Wasn't complicated at all. One vector that we just turned over. We end up having the shape that we need. Again, it's double-sided, which is really kind of nice. You'll see that I've got an extra vector here. That was a test vector that I decided to change later. Again, a nice thing about having this part on its own is I could mess around with things without affecting a whole bunch of other stuff. So in the end, we decided to make the collet just slightly smaller. And it made a little bit more sense in the end. We've got our left and our right jaw, which again you saw earlier. We have the arm socket. Now this is the part of his sleeve or his shoulder that covers up the connection of his arm hose into his chest. And this was actually two different parts. If we take a look at the illustration that we are given here, it's actually two pieces. And I decided to do them separately. That way I could get some of these complex curves in there nicely. And I think it turned out pretty good. So this here is the first part. And if I go to my modeling tab, you'll see that I can go ahead and turn on the other part, turn off the other one, and you can see how they fit. They're actually modeled on the same sheet. Now they'll be glued face to face, so I couldn't cut them again at the same time, but I did accommodate for all that. And we'll actually leave a bit of a thick border there so we can glue them and screw them together much easier in the end. But for a model, this is exactly what I needed to start with. Now the cutter, the V cutter, it's a stylized V-bit, which we really wanted to kind of capture that because it had to look a bit cartoony. And in the end, I think it turned out pretty good. We used a really basic two-rail sweep here for the bit, which wasn't too complicated, or the cutter, the blade, a simple sort of shape creation for this part, a couple blobs that we added to the top, and I just cropped it off to the shape that we needed. That's all those were, and then a quick little turn to make the top of his V-bit there. And that looks pretty good. That turned out really nice. Again, a double-sided part, so that was really good. And we have the hose, the glove, the pendant, the cover for this, the CNC logo for the other arm that he has, and then the finger. Now, oddly enough, the finger became one of the most important parts that we made because we used this so that we could test paint colors and so on it, and also I could fit the fingers in between everywhere's all the other parts, sort of as filler parts if you'd like, amongst all the other bits. And we only really cut, it's a double-sided part, so we only cut from here up, and that was exactly 50 millimeters, so we didn't have to worry about having to slice or re-glue anything up at all. We just had to glue the two parts together. And the nice shape of this, the round sort of wheel end here, was great for affixing it to the inside of his sleeve. All I had to do was drill a hole and put in a dowel, and then I could go ahead and insert that into the bottom of his sleeve. Yeah, and that's pretty much it. Again, this is a great use of sheets. It's really important. Again, I can't say this enough, that a complicated job like this, take it and break it down into smaller bits and work on those individually, and that will actually, not only does it make the job kind of seem much easier, it also gives you this sort of feeling that you're actually progressing along through a job in decent chunks, and you can show those chunks off to people. It really is a nice way to create a huge project like this.
Now that I have all of his parts modeled up, wouldn't it be great if we could see Victor as a whole? Well, we can do that as long as we use a third-party piece of software. So what I did was I went and I exported out all of his parts as STL models, and I imported them into a third-party piece of software so that we could lay him out and we could make sure that he looked exactly like what we wanted him to be. Once we were happy with that, then I had to go ahead and start to think about how I was going to slice him up and put them on all the different sheets. Now let's go ahead and have a look at a couple of those files that I used to do this with and some of the considerations I had to put in mind, or I had to keep in mind, when I was breaking them up so we could get them all back together again.
This is one of the working files that I used to create the final sheet layout for Victor's parts. Now, I can't show you everything that I had to think about during this build, but I did want to point out some of the interesting parts. So first of all, let's have a look at test sheet, or my test plus nut sheet. So first of all, before I did anything at all, I had to come up with a way to make sure that I didn't run into any screws. So you see I've got these little squares at the corner of these sheets. That's just kind of reminds me that I can't have any part that goes into that space or gets too close to that space. That way I won't run into the screw that I'm going to use to hold down my HDU with. I have a section here. These were the test parts that I initially cut first of all. So a mock-up of Victor's light bulb, sliced up so that we could try the glue and we could try the sanding technique, and we could also try some painting techniques after that was all done. And that was really quite handy for me to get going. Now really, the thing that I learned the most from this particular part was what feeds and speeds I could get started with. Now later on, Sean came down and gave me a bit of help, sort of nudging me along to really kind of increase my feeds and speeds, because I was only cutting into HDU, which was fantastic. That was a huge help, saved tons of time. So thanks to Sean for his input there. Also, we have this part right here. This part was really important. This was the part that I was going to use to test the locking mechanism. I was going to use to lock the bolts inside of Victor so that we could affix them to the wall. And I'll point that out a little bit later on, but this test part was really, really important, so I could really give that a good try and make sure that it was going to work okay, and convince some other people in the team that the idea was actually going to work. And so that was perfect for that. Now you see this is the nut. The nut actually was sliced into two pieces. It was about 100 millimeters thick in the end. And then I had to accommodate how we were going to put the collet, or center the collet into the bottom of it. So that's why you have these pockets, and I added some bits to the top of the collet so they could be put into so that they would fit in the right spot. You'll see the back of the nut is actually cut off because of the way Victor was going to be affixed to the wall. He had to have a flat back. So all of his parts were cut in 50 millimeter slices starting from the center point. So his front was from the back forward, and his back was again from the back forward. And I actually didn't use the last two slices. We actually deleted those, didn't use those at all. That way I was sure he had a nice flat back that could go against the wall. We have a socket here. Another great thing about working this way is that I could add notes into my file, so I could remember what I needed to do when it came down to tooling, or the next time I opened up my file, I would have little cues here so I knew what I needed to do next. We used his fingers as filler parts. As you can see here, we got all kinds of different half fingers around. We have his V-bit here, which has been sliced into parts and so on. If we want to take a look at this sheet, it is kind of interesting how it all kind of looks in the end. If we take a look at the 3D view, you'll see all of his parts. So we have the back of his V-bit, or these two pieces get glued together. We've got the piece at the top that helps me to line it up in the center of his collet. We have lots of finger parts here, and then these pieces here get glued onto the fronts of these. And then these two got glued together again. So we had this full 3D V-bit going on, which was really kind of neat. Now we also had time to think about how we could save some material here, and so that's what we used these sliced up and these extra vectors for here, is that we could actually go in and cut out parts of these that we didn't need. So this was inside of the actual collet. It could be hollow. Along with, I wanted it to be hollow, so if Sean needed to feed any wires through there, we could do that. Also, it reduced the weight of Victor, which ended up being quite heavy in the end, which was quite surprising that, that we were just using foam for him and he ended up being so heavy. But that worked out really well. And that's that part. And you'll see that I have more notes here for myself to remember. And we have the arm. You saw me slice up the arm earlier on in this presentation, which looks really neat in the end. It worked out really well. And I added this lump to it so that we could put that inside of Victor. Now, this wasn't the finished file. I actually had to change this in the end, but we did decide in the end not to use the silver conduit, the silver piping from a dryer. We decided to actually just cut it. And in the end, if it failed or didn't look all that great, then we could replace this with something else. But in the end, it did work out okay. But those are some parts of his arm. It's got holes in these that we're going to use to actually, when we insert his arm into his body, we're going to slide a piece of dowel in through his back, and that will lock these in place. We were a little worried that during transport, his arms might break if they're hit the wrong way. So we thought this was an easy way to transport them separately and then assemble them once we were on site. That was good. And over here we have the socket and arm extensions, or arm extras. And again, we've got those pieces that go on his shoulder with that extra bit I mentioned earlier. Nice, so we can glue these together and screw them together. And we have the face plate for the actual monitor, so that way we get access to the front of the monitor if we needed to while he was on the wall. And we use magnets actually to hold that in place, which is kind of neat. Now, the other really important part about this file is that when it came to actually slicing up his head and chest, I needed to put a lot of thought into that. One was, first of all, we needed to lighten the load. So we needed to be able to, again, cut out some stuff out of the center of him. He needed to have enough support that he wouldn't collapse. And I needed a way to put him back together again. So I used this vector right here to slice the side parts of his body so that we could actually kind of put them back together again with this sort of locking mechanism. And that worked out really well because, as you can see, his chest is actually wider than our sheet of HDU. So I had to do that in order to get it to fit. And that way we could actually nest these together a little bit easier. I also used this part of the file so that I could make sure that I had removed the parts of his chest where his head needed to fit together. Keep in mind or remember that I had modeled his chest separate from his head, and they never come together until now. And so I needed to make it so that his head could rest on his chest properly. And so that's what these vectors are for. Now let's go ahead and have a look at the next file. And the important part of this file is I can actually show you how this was, how I nested it by hand onto my sheet. So if I look at my 3D view, this is actually some tooling as well that I've got set up. And with these parts, I only wanted to cut the 3D sections of these parts. I didn't want to worry about these flat faces. This one here I changed the tooling in the end for, but you can see that this is just a test so I could see how things are going to cut. These flat was just the surface of the actual HDU, so only did a 3D cut through these sections here. Roughing in some cases, but most of the time it was just a quick finishing pass, so I didn't actually do any roughing here in my tool pass. It was straight through in this HDU with a long cut ball nose, and I just went right at it, and it worked out really, really well in the end. Now this is the first time we're going to start to see this locking mechanism that I had set up. So keep in mind that these two pieces fit together, and this piece here fits on the back of that. Okay, so this will be a small pocket where the head of the bolt will fit into, and it will come up directly towards you through this slice here, and the bolt will stick out. Now the nut, we're not actually going to cut this all the way through. It's only going to be cut in this layer, so that what happens is the nut head won't be able to turn in here. It gets locked in place, and we can go ahead and bolt it against the wall, and it won't pull through this back layer of HDU. And that again was why I ran this test part up here to show that that was going to be strong enough. So if we torque that bolt any, it wouldn't tear that HDU. And it worked out really well in the end. Really, really well. And you'll see that in this file, I was working along, again, slicing things up to make sure that they'd all fit on the HDU like they should. Now let's have a look at the next file. We're getting close to the end of this, and as you can see, I've got almost all of his stuff here, and it all fits on all of the 14 sheets of HDU. Thank goodness, because that was just a guess on my part that was going to be enough sheets to make this work. And so I got all of the parts all laid out, and the last chest piece I needed to work through here. Again, this is the vector that I used to slice this this component in half along that vector, and then I actually cropped out the center bit using this inside vector. Now these offsets are all exactly the same width, so when you go ahead and when I glued them up, I knew I had enough surface there to go ahead and glue and also screw into. And this is the last sheet for his actual chest, which is really kind of neat. There were some thin parts here, but that's okay. But this faceplate fits right on top of there. And then I've got some other pocket details here so that I can go ahead, and in my tooling you'll see that I've got some pockets set up here for the frame and for his actual where his monitor is going to go in here, which is kind of neat. That was one of the first sheets that we cut, and that was so that we could go ahead and test fit the monitor in. If I needed to make any changes, then I could do that before we went too much farther. And now let's have a look at the last file. Here we have everything all ready to go, and I filled up all of the extra spaces with extra fingers that we could use in case any of them broke or we needed to test any more paint colors or anything like that. Then we could use those. So there's all kinds of fingers all sort of scattered about all of these different sheets. On this sheet here, got a part that I created that was kind of interesting. It's actually a piece that holds some screws for his chest and those rivets. We decided to cut those separately and then glue them on later in the end. Or actually, we hadn't decided that right yet. I just wanted to have this around in case we did decide that, and then we could go ahead and glue them on, which is what we did. We actually had them here cut in place. But then we decided that we would remove those and just use the ones that I cut straight up and down, which was kind of nice because the actual bolts with the screw heads in them, they looked a little bit distorted because of the way they laid on his chest and the way they were cut. So being able to cut them straight up and down meant that they actually looked like real bolts, which was kind of nice. And so that's the end file. That's the culmination of all of the work that we did through modeling and slicing, and now it's just time to get in there and cut this.
It really is amazing what you can do with Aspire and some out-of-the-box thinking. I'm super proud of the team here at Vectric. We managed to achieve an amazing thing. Victor is truly incredible. If you have any comments about this build, please leave them below. If you have any questions, I'll do my best to answer them. Just leave those below as well. Until next time, happy making, and we'll see you soon.